Alright, this is the last day of section 4.1. What we're going to do today is look at some acceleration, velocity type problems. So this one says use A of t equals negative 9.8 meters per second per second. So that means meters per second squared is the acceleration due to gravity. So let's go ahead and start with that. And what I'm going to go ahead and do is write down that A of t is equal to negative 9.8. The Grand Canyon is 1,800 meters deep at its deepest point. A rock is dropped from the rim above this point. Write the height of the rock as a function of the time in seconds. So basically, we're being asked to find the position function. You could memorize the position function as I've stated before, and we could get directly to the answer. But I'm going to show you how you can use integration. So you don't have to memorize that. So when you integrate this with respect to t, we would get back to the velocity function. And so our velocity would be negative 9.8 t plus c. Now, we do know that the initial velocity is 0. We know that because we're standing there holding the rock. So that means at time 0, the velocity is 0. So I could plug in 0 and 0 so that I can find c to be 0. So what that means is my velocity function is just simply negative 9.8 t. And I don't need to put plus c because it would be plus 0. So the next thing I'm going to do is go ahead and change this, and I'm going to integrate it so I can find the position function. So I'd get negative 9.8 t squared over 2 plus c. Now in this particular part, we know that the initial position is 1,800. So at time 0, okay, this is actually negative 4.9, plug in 0, we get c to be 1,800. So my position function is s of t equals negative 4.9 t squared plus 1,800. So that's one of my solutions. The second part they want me to do is find out how long it will take the rock to hit the canyon floor. So that means that we're going to take our position function and we're going to set this equal to 0. Because we want to know at what time will the position be 0. So when we solve for this, we can bring the negative 4.9 t squared to the other side. We will divide by 4.9. So we have 1,800 divided by 4.9. And then what we're going to have to do is square root that. So t ends up being the square root of 1,800 divided by 4.9. That's the time at which it takes for the rock to hit the floor. Let's try another one of those. So once again, I'm given that the acceleration is negative 9.8 meters per second squared. And this time I know a baseball is being thrown upward from a height of 2 meters with an initial velocity of 10 meters per second. So I know that at time 0, the velocity is 10. And I also know at time 0, the position is 2. So we're going to use both of those to come up with our position function. Now, if you remember the formula, s of t equals 1/2 g t squared plus v sub 0 t plus s sub 0, and I could have done this on the last problem as well. I can get directly to the answer. I can just say it's 1/2 of the gravitational pull, negative 9.8 t squared, plus my initial velocity, 10, plus my initial position. And most of the time, people are not memorizing this or remembering the formula, so they aren't able to do it in this method. On the next video, I'll show you how you can use integration to come up with the same solution.